Hi, it's time for another little video on forces, and we're using force diagrams today. Instead of, if we had a parachuting cow, as what I've got showing you here at the moment, then it's really hard to draw. So we've got to work out ways of doing some little force diagrams to show us what's actually happening. And even though some of us are better drawers than others, this one is fair for all. Alright, so when we're using force diagrams, we use arrows, and they point in the direction the force is directed. So the force is pushing or whatever, the force is acting. So if we've got a force acting to our right, the arrow goes to the right with the arrowhead over here. If we've got a force going left, it goes that way. If it's going up, pushing up, it goes that way. If it's pushing down, it goes that way. Now keep in mind, sometimes forces are on angles. That becomes a little bit trickier, but we might be able to asking you to do that. Now in our force diagram, we also should name, or try to name, the force. And occasionally you'll even see force diagrams which have numbers on them, and that makes it a little bit easier to work out what's going on. So let's have a look at this one. I've got a book and it's sitting on top of the table and nothing's happening. So we know that gravity is pulling on the book and dragging it towards the centre of the earth or downwards. So this would be the effect of gravity. And as we found out before, the effect of gravity is called weight. But on the other hand, we have a force pushing up. We know this because the book is sitting on the table. So this force pushes straight up, and it's based upon the table itself pushing up. Now sometimes people call this the normal force. Let's consider a parachutist. We had the parachuting cow before. Unfortunately, I can't draw cows, so we have this. Now in this case, we've got a force again acting up and a force acting down. This time, the force acting up is all of the air itself, and we call this air resistance. Some people call it drag. That's D-R-A-G, the drag. Alright, now it's acting up, so it's slowing this force pulling us down, which is our weight. Now we know that weight is bigger than air resistance because the person doesn't stay floating in the air, they eventually reach the ground. So that means this force pulling down must be bigger than this force pushing up. So that's one way we can tell it. Now if you look ever so slightly, you can see that this arrow is a little bit smaller than this arrow. That was more by good luck than anything else. But that is a way we can actually show the difference in sizes of forces too. But what we normally do, for those people who cannot draw, we use squares, boxes, or even circles or balls to show the object. So in this case, both these cases, the object is shown as a red box. Right? In the first case here I'm with now, someone is pushing that box to the right. I know because the right hand pushing to the right is labelled as push. Now the box is rubbing on the surface, and as we've seen, friction is a force between two things rubbing together. And friction is actually trying to stop it going that way, so it's pushing that way. That's a bit tricky sometimes. Right, now this would be what our diagram would look like for our parachuting cow. Right, we have our object here. The drag force is acting this way, upwards, and the weight force is acting downwards. Now this time I didn't pay too much attention to the size of the arrows. I think they might almost be the same. And as we know, of course, our parachuting cow will eventually reach the ground. Right, more about this later.